The Mars Reconnaissance orbiter launched on August 12, 2005 at Cape Canaveral Air Force Station, Florida, and is still orbiting today. The purpose of the mission was to study Mars from orbit and learn about the geology, climate, and habitability of Mars, as well as relay information back to Earth and look for future landing spots. The MRO includes a main bus made of titanium, carbon composites, and aluminum honeycomb. Extending from the bus are two solar panel wings that power the orbiter. The bus takes care of propulsion systems, telecommunications, command, guidance, and science instruments. There is also 3 scientific cameras to study the surface and weather patterns, including the HiRes, which helps capture high-resolution photos to study the geology, the Prism, which analyzes the composition of minerals and chemicals on the surface, and the Marcy, which helps monitor the weather patterns like dust storms and cloud patterns. From March to November 2006, air braking was used to slow down the orbiter and come closer to Mars so that they could observe the planet better. Air braking is a maneuver that uses the drag from the orbiter and the control of the thrusters to move. The MRO has had many key discoveries, including the finding of soil minerals as recently as 2 billion years ago, indicating surface water, studied seasonal carbon dioxide snowfall occurring in polar regions, active gullies on Mars' slope, meaning there are geological processes involving liquid water, and finding impact craters, helping us learn more about the geology of the planet. The Mars Reconnaissance orbiter also had to overcome many challenges of space. The thermal control system of the orbiter handled the extreme temperatures of space using insulation, heat sinks, and heaters. There is shielding for different components using aluminum, which protects it from radiation in space. The MRO was designed specifically to withstand space using pressure vessels and sealing systems as space is a vacuum. Solar panels were used to power the orbiter throughout the mission rather than relying on fuel. It also uses NASA's Deep Space Network to communicate from long distance, allowing information from the orbiter to go to Earth. During takeoff, the Atlas V401 helped launch the orbiter into space, as that was a challenge. The environmental impact of the MRO is that it burns a lot of fuel, which is harmful to the environment, although there is less of an impact due to it being an orbiter rather than a lander. The ethical impact is that it allows for advancement in scientific knowledge and helps us learn more about Mars. The economic impact is that the MRO has a total cost of $716.6 million, although more than half of the Mars missions are unsuccessful. This mission has been successful as the MRO has returned over 445 terabytes of data. It has captured many images of Mars' surface and allowed us to learn more about Mars and its geology, climate, and habitability.